Hello and welcome. Today we'll be looking at part 2 of chapter 19, Oscillations. So now we're going to look at what is a simple harmonic motion. We will define the simple harmonic motion a bit later when we do the graphs. So we will just look at the requirements and examples of simple harmonic motion first. So firstly, what is simple harmonic motions? Examples. For example, when a vibrating string of a music instrument keeps on vibrating at the same note. Okay, we've seen the tethered trolley, the trolley between springs. That is another example of simple harmonic motion. We've seen the pendulum as an example because it goes back and forth. But then there's a few other things. For example, in a sound wave, the air molecules vibrate back and forth with a simple harmonic motion when there's a single tone moving through or single sound moving through the air. Alternating current flows in a wire. The electrons flows in alternating simple harmonic motion, and then the atoms in a molecule also vibrate with a simple harmonic motion. So there are different applications to this, and you can see how they can combine it into different chapters. Now, what are the requirements to have a simple harmonic motion? Firstly, there are three requirements of a mechanical system. There has to be an object with a mass that oscillates. Okay, there must be a position where the mass is in equilibrium, and there must be a force that restores it to return the mass to its equilibrium position. So if we look here, we have a mass that oscillates. It has a equilibrium position in the middle, and there is a restoring force that brings it back to the equilibrium position each time. So this is classified as a simple harmonic motion. Here we have a mass that is moving. There's an equilibrium position in the middle, and there's a force restoring it back to its equilibrium position. In this case, it's the force of gravity, the weight pulling the pendulum down, making it accelerate to the bottom and then decelerate and stop as soon as it's past the equilibrium position. Next, we will look at changes in velocity in a simple harmonic motion. So once again, here at the bottom we have a simulation of O-Physics, the website, and here we have a mass. It's got an equilibrium position in the middle. It is oscillating, and it has a restoring force, which is the spring. Okay, so if we want to look at the speed or the velocity here, what we're going to see is it stops, it accelerates to the equilibrium position, decelerates, stops, then accelerates in the opposite direction, decelerates, stop, change direction, accelerate, decelerate, stop. So there's always this continuous velocity change. The velocity is never constant. It's either accelerating or decelerating, or it's stopping to change direction at a continuous pace.